the derivative or the rate of change when A is 10,000. Awesome. Good. So here is, oh, I should have not taken away. Can anyone differentiate this function for us? N prime. Oh, sorry, I'm still sharing. Yes, right here. This is the function, and we want to differentiate it to find the rate of change. Can anyone differentiate this for us?
I can give you the answer.
Yes, I'm ready.
It's 1,200.
So we differentiate 1,000. What is the derivative of 1,000?
It goes away.
Good. Now we differentiate the product 200 times natural log A. What do we get?
Just 200.
Zero.
1 over 200.
So we have 200 times natural log A. Why would I put 200 in the denominator? Does it have power -1?
No.
No, it does not. So then nobody can touch it.
Okay.
So then the derivative will be
200 over A.
Thank you very much. 200 over A. Awesome. We're asked to plug in 10, so this will be 200 over 10, which is 20. Measurement unit. So remember, N is measured in units. A is measured in thousands of dollars. What does 20 represent? The measurement unit.
Is it just 20 units?
So remember, the rate of change has 2 measurement units. 2, always. When you see N prime or F prime, just remember we are like looking at the velocity. So when you ask me what's your speed, I'm not going to say 20 miles. You will say, you will say to me, that's wrong. And I will say, oops, sorry, it's 20 miles an hour because it's the rate of change. Ready?
Would it be 20 units sold?
Units per
$1,000.
Thank you. It's 20 units per $1,000. This is measured in units, and this is measured in thousands. So I'm really hoping that we're in the middle of the second month. So we've been talking about this for 2 units, 2 measurement units for quite some time. Please, I'm begging you. There is no rate of change that has only 1 measurement unit. I will not tell you that my velocity is 20 miles. You will say, nope, that's not possible. Your velocity is 20 miles per hour. 2 measurement units. This is the distance prime. Okay, good. What else is there? Let's go back. How much should we spend on advertising if 1,500 units are to be sold? So this is now the number of units. So this is part C. N equals 1,500 units. So they want us to find how much should we spend on advertising? What is A when 1,500 units are sold? Okay, how do we do this? Yes?
Separate the natural log of A. So you do 1,500 minus 1,000. And then divide.
So you wanted to set that equal to. Okay, so everyone can see that. Awesome, I completely agree. So Hubert already showed us the second step, subtract. So we have 500 equals 200 natural log A. Good. What will be the next step? continue cleaning it up. How do I clean it up? Yes?
Divide by 200.
Exactly.
And the natural log of
Yes.
that number.
5 over 2, careful, equals natural log A. This is already,
Now,
this is a log equation. We want to convert it into an exponential equation. How do we do that?
would you just raise it to the e power?
Say it
So
again.
You would raise it to the e power. So e to the 5 over 2.
Yes, because the base here is e. E to this power equals a. Very good. Awesome. I'm going to share my screen and calculate this. Where are you guys? I can't see you now. Okay, here you are. So we go to e power 5 halves, which is 2.5. You know I love my parentheses. And I got 12.182. So A equals 12.182. What does it really mean?
If you want to sell 1,500 units, you have to spend $12,000.
Yes. 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 Because A is in thousands, so I have to multiply this by 1,000. That's the reason why I choose to put in or copy 3 decimal digits. Awesome. Awesome. There is another question here. Where is it? Where is my book? Okay. Discuss the limit as A approaches infinity from n prime of A. Does it make sense to spend more and more and more and more and more on advertising? Why or why not? So I have to look at this limit. So the limit as A approaches infinity, number of dollars, thousands of dollars goes to infinity. Not possible, but you know what I mean, more and more and more and more of n prime. If the rate of change, so let's take a look. So this is part D. The limit as n approaches, as A approaches infinity from 200 over A. That was n prime. So they want us to find the limit as A approaches infinity from n prime of A. What is the answer? As A approaches infinity,
is it 0?
Yes, it is 0. So after a certain while, you should not continue spending more and more and more and more and more on advertising because you will not make any sense. You're not going to increase the number of units sold. That's it. So this is the horizontal asymptote. As A approaches infinity, the rate of change. Sorry, it's not of the function. Sorry, I take that back. It was from the derivative, not from the function. Sorry. So as the number of thousands of dollars spent on advertising increasing and increasing, the rate of change, not the number of units. This is the rate of change. This is n prime. For a moment, I forgot that this was n prime. So the rate of change approaches 0. So it will not go higher and higher. It will not increase, in other words. Good. Awesome. That's basically all I needed to say. Let's see if we want to look at another word problem. If not, we are ready to start chapter 3. So let's take a look at this kind of function, which is slightly more involving. So let's take a look at that. So that's my page 4. So number 31. So I'm going to copy. I don't like these notations. T of t. I really don't, but because it's difficult to keep up with. They should have used different notations. But anyway. So the time t in minutes. So I take notes. So this is minutes. Needed to allow a cup of cold water. We've looked at that. Placed in a room to warm at T degrees Celsius. So this is in degrees Celsius is given by this function. Find part A, find t of 15 and t prime of 15, and explain what each number represents. Measurement unit, in other words. Okay. So how do I find the first one? Anyone? How do we find the first one?
Plug 15 in for T.
Of course. So 25 minus 15 is 10. 25 minus 15 is 10. 15 divided by 10 is 1.5. I have no idea what that means, but it's very easy. 50 natural log of 1.5. 20.3. Measurement unit. So 15 degrees Celsius.
20.3 minutes.
Excellent. Great job. Good. Now, in order to find this, what do I have to find first?
The derivative.
Yes. So first we have to find this t of t. T of t. I don't like that, but it is what it is. Okay. I look at this function. This is a constant in front as a factor, no problem. But when I look at this, I realize that the numerator does not have the variable. Because the numerator does not have the variable, I prefer, this is my preference, to change this into 15 25 minus t to power negative 1. Why? It's easier to differentiate. You can say, no, I want to differentiate the quotient, but you have to be careful because the numerator prime will be 0. I recommend this, unless you can handle that with no difficulties. I recommend this only because there is no variable at the top. Otherwise, I will not do this. So, 50 times natural log. Okay, 50. Can anyone tell us how to differentiate? So don't look at this just now. How to differentiate natural log of a function? Natural log of this function. What do I have to write first? Whatever the function is, I don't care. What do I have to write first?
E.
Say it again.
E.
No.
Okay.
So let's go back to the formula. Let's go back to the formula.
Would it be 1 over
The whole thing. Stop for a moment. Awesome.
15 times?
Exactly. 15 over. No. This is coming.
Oh,
It's
15
coming.
over
It's coming.
25
Yes.
minus t
Good. Times.
times f prime, which would be
Yes. Now we look at this f prime. And I'm ready.
f prime would be negative 15 times 25 minus t
To which power?
to the negative 2 power
Times the inner function prime.
times negative t
Times
negative t
times
Is it 1?
negative 1. Very good. Now this looks awful. If you say it looks awful, I have to agree. It does. So take it slowly. 50. Flip this, because it's a function, a fraction over another fraction. 25 minus t over 15. Negative 15 times negative 1, 15. And leave this alone for a moment. (25 minus t), bring down this. Oh, how nice. Yes, we went through a little bit of a, a little bit of a hoop here. So to make it as easy as possible, let's review this for a moment. 50 stays outside. I differentiate natural log of a function. When I differentiate natural log of a function, I have 1 over the function times that function prime. But when I differentiate it, I prefer this form. I bring down negative 1. I subtract 1 from the power. And I can never forget those magic words, times the inner function prime. Now, 50, flip, multiply these two numbers, and keep 25 minus t to negative 2 as is for the moment. Simplify these two, copy the 50, copy 25 minus t, bring this down with a positive power, get rid of one of them from the top and one from the denominator. 50 times 1 is 50, and I still have 1 left. Now I can determine this. I could not without determining the function first. So then, t prime of 15. 25 minus 15 is 10. 50 divided by 10 is 5. We need the measurement unit.
Degrees Celsius per minute?
Careful. It's always the y variable. I know it's silly. It looks silly, and I completely agree with you. But it's always the y variable over the x variable. It's confusing. The TT, I don't like that. But it's always the y variable over the x variable. So it's minutes per degree Celsius. I know it kind of doesn't make sense, but that's how the function is given to us. Awesome. Was there something else in there? Yes. What is the water's temperature after 1 hour? So they want the temperature after 1 hour. Am I still centered? I think so. So temp, which is T, after 1 hour, which has to be in minutes, it has to be 60 minutes. I cannot plug in an hour in a formula where T is guaranteed and or has to be in minutes. So I have to change the time from 1 hour to 60 minutes. They want us to find the temperature. How do I do that?